We are still solving logarithmic equations using different methods. In this video, we'll be looking at how to solve logarithmic equations using log laws, using the laws of logarithm, which we considered in the second video, I believe. So this lesson explains how to solve logarithmic equations systematically using log laws with complete worked examples. First of all, let's remind ourselves of the laws. In one of the videos, I stated up to 7 laws, and we're probably going to encounter all of them. But the first four we are listed here that we're listing here include the following: that the product is the first. The first one is the product law, right? When you have log A, of course, we have said it already that when the base is not written, just take it as base 10. It's either you have log or ln. So if it is log, that's base 10. If it is ln, that's base E, log to base Z. So log A plus log B equals log AB. That's the product law. The converse is also true that log AB is log A plus log B. Quotient law says log A minus log B is equal to log A over B. Power law says log of A raised power n means n log A. Then number 4, definition of logarithm in base 10. So if you have log A equals 1, that implies that A is equal to 10 raised power 1, which is equal to 10, like that. Okay. So that means you're dealing with this base here. Okay. So with all of that of course, there are other rules like when the base is a fraction, maybe the base is like 1 over 2. So what that's simply going to do is that it's so for instance, okay, I think let me just add that as a reminder. So if you have log A, log A to base 10, log A to base 1 over 10. That's the same thing as minus log A to base 10, basically. Okay, so we have that. We also have this one that if you have log A to base 100, okay, that means you have log A to base 10 raised power 2. That is simply the same thing as half. This 2 now becomes, you now have half. So that's half log A to base 10. So we have this also. So we might need any of these ideas as we move on in trying to solve using the laws of logarithm. Okay, so 16.2 now we have important rule about domain restrictions. Of course, we did domain restrictions everywhere so far since we started solving logarithmic equations. So important rule for domain restrictions for any logarithm, the log A for any logarithm log A, the argument must satisfy that A is greater than 0. A must always be greater than 0 no matter what. So always determine restrictions before you solve. So before you start solving, like we've done in every video so far, you must ensure that A is positive. Whatever A represents is positive before you start solving. If not, it will just be an exercise in futility. So imagine now that you have log x minus 1 plus log x plus 1 equals 1. Okay, before you start solving, determine the restrictions first and see if they agree. So here you have that, first of all, this x minus 1 must be greater than 0. So if for x minus 1 to be greater than 0, that means x is greater than 1. On the other hand, for x plus 1 to be greater than 0, that means x is greater than minus 1. So if you, like we've said already, so if you have less than, or greater than, at the end of the day, if the signs are not opposite, like if this was greater than 1 and this was x less than minus 1, then there's no point even trying to solve because they don't agree. So you can't really get any solution that satisfies the situation. But here, x greater than 1, if x is greater than 1, it's automatically greater than minus 1. So that is why the combined restriction will be taken to be x greater than 1. So this is what we are solving. And now you have established that you have a combined restriction, then we can go ahead and use the laws of logarithm to take care of this. So from what we have, right, you can see you have log x minus 1 plus log x plus 1. That means they have the same base 10, right? So it means you can combine them using product law. Now that we know that we can actually work with it. So log x minus 1 plus log x plus 1, using product law is simply log so from the first order, log a plus log b is equal to log ab. That means log x minus 1 plus log x plus 1 is log x minus 1 x plus 1. So the equation becomes now that from the original equation, right, you have the left equals 1. So it means you now have log x minus 1 into x plus 1 equals 1. And the next thing is we can then write it in exponential form. So to write in exponential form, since the base is not written, that is base 10. So it means that the base can then carry 1 on it. So you have 10 raised power 1 is equal to x minus 1 into x plus 1. So that means log, of course, if this whole thing is a now, so log a equals 1, that means a is 10 raised to power 1, right? So we can then say that x minus 1 into x plus 1 is equal to 10. Just imagine that you have 10 here as base, so 10 raised to power 1. So you have this expression now equals 10. So we can then take care of this. So you have this now. So if you expand this, I mean, it is even difference of two squares will give you this x minus 1 into x plus 1 will give you x squared minus 1. So you have x squared minus 1 equals 10. That means you have x squared equals 10 plus 1, which is x squared equals 11. And that means x is equal to plus or minus square root of 11. And don't forget the combined restriction that x has got to be greater than 1. Because x has got to be greater than 1, then, and here you have two answers, right? You have x to be plus or minus 11. Since restriction says x should be greater than 1, and we know that square root of 11 is approximately 3.32, or even without getting this, you already know this is something bigger than 1 already. So, but minus root 11, because of the minus already, it's going to be, it's less than 1 in that case. So we know we have to reject the negative and take the positive. So only square root of 11 satisfies that x is greater than 1, and the final answer there is that x is equal to square root of 11. That is the only thing that satisfies this expression right here. Okay, that's the only thing that satisfies it. So you can just I could have tried to test it. I mean, we can do that, right? That'll be log root 11 minus 1 plus log roots 12, and that should be approximately 1. So let's go decimals and see. As usual, decimals helps with this. Decimals. Okay, so we go for this and this now. So we have root 11, log of root 11 minus 1 plus log of root 11 plus 1. So we have log of square roots of 11 minus 1 plus log of log of square roots of 11 plus 1. Okay, so you see it gives us 1 clearly. That's what it gives us. So we are good to go. All right, so you can check like that to be sure your answer is correct. Then example 2 now, we have this log 2x minus log x minus 3 is equal to log 4. Okay, so here, what do? You determine the restrictions. First of all, 2x has got to be greater than 0. That means x must be greater than 0, guaranteed. Then x minus 3 must be greater than 0. That implies x is greater than 3. So if x is greater than 3, it's automatically greater than 0. So the combined restriction is that x should be greater than 3. So if that is the case, we can go ahead and apply the laws. So now we have that, log 2x on the left-hand side, log 2x minus log x minus 3 can be written is applying quotient rule because it's negative subtraction. So that can now be log 2x over x minus 3, then equals log 4. Okay, so you then have, so this whole thing now is log 2x over x minus 3, and that is equal to log 4. In fact, you can even bring log 4, and it becomes minus log 4. So you further divide by log 4, but then you can also compare, the things in front of the base. So you have log 2x over x minus 3 equals log 4. So that simply means we can compare the two. So you can then remove the logarithms because now log a is equal to log b, same base. So you can then say a equals b, that's 2x over x minus 3 equals 4. Okay, so we have 2x over x minus 3 is equal to 4. And then we can easily solve this by multiplying through by x minus 3. So you have multiply both sides by x minus 3. So it cancels out from here. So we have 2x equals 4 into x minus 3. Then we open up things. So 2x is 4x minus 12. So 2x minus 4x minus 2x. Then you have minus 12 here. Divide both sides by minus 2. We get 6. So x is equal to 6. If you check the restriction, the restriction says that x should be greater than 3. And since 6 is greater than 3, the solution is valid. So our final answer here is that x is equal to 6, like that. So overall now, we see that the systematic method for solving logarithmic equations is such that, first of all, you determine the domain restrictions, then you use log laws to combine logarithms, you rewrite in exponential form or remove logs, solve the resulting algebraic equation, and check for extraneous solutions, that is, solutions that don't fit, and always verify that solutions satisfy the original logarithmic restrictions. Very important. So we come to practice questions where I get to solve two questions in this case. To solve which equation, state any restrictions and check for extraneous solutions. So which should I go for? Which should I go for? Nothing has a quadratic term, so I think I'll just pick anyone at random. Okay, as usual. Okay, let me pick question 9. Question 9 looks like what I should deal with. So I'll pick question 9. So I'll just snip it like this, and then I'll copy this to the worksheet. Okay, like this now. So I'll copy it here, right click and paste. So we need to solve for x, right? So of course, all the bases are the same. So the next thing we want to do is to check for the domain restrictions. So first, we talk about domain restriction. Domain restriction. We have 3 instances here. Okay, 5 is clearly greater than 0, so no problem. So first of all, 5x should be greater than 0, and that implies that x should be greater than 0. So that's one. Next, we have 2x minus 1 should be greater than 0. That implies that 2x is greater than 1, which means that x is greater than 1 over 2. So, and if x is greater than 1 over 2, it's automatically greater than 0. So, we have combined restriction, or combined domain restriction, if you like, is that x should be greater than 1 over 2. Okay? Because once x is greater than 1 over 2, it's automatically greater than 0. So we have that now. Then we can go ahead and solve like that. So to do that, we then have, we want to apply the laws of logarithm. That's what we're doing. So then let's step 2. Now we have log 5x minus log 2x minus 1, log 2x minus 1 equals log 5. Okay, that's log 5. So here now, this is subtraction. And what talks about subtraction is the quotient law. So if log, then you can recall that log A minus log B is equal to log A over B. Okay, we have to recall that. So once we can then use that to say that now we have log 5x all over 2x minus 1, all over 2x minus 1, and that is equal to log 5. And now, uh, uh, if log A is equal to log B, okay, that implies that A can be equal to B. So we have that idea here now. So that means this is equal to 5, okay? So we then have 5x all over 2x minus 1 equals 5. So we can then multiply through by 2x minus 1. So, or cross multiply like they say. So you have 5x equals 5 into 2x minus 1. So that means that you have 5x equals 10x minus 5, okay? 10x minus 5. Then you can collect like terms. So you have 5, you can bring this 5 back here, and you can bring 5x here. So you have 10x minus 5x. You could do it the other way, but I try to avoid minus as much as possible. So 5 is equal to 5x. So if you divide through by 5, that means x is equal to 1. Now, x is equal to 1. Does it agree with the domain restriction? The domain restriction says x should be greater than half, okay? Since x is greater than half, I can just go and say, since 1 is greater than half, then x equals 1 is valid. So that's a valid solution for that problem, okay? So we go again to see questions 11 to 20 and see which one we should deal with there. Which one looks really challenging? Yeah, they look pretty easy. Which one should I go for now? Okay, let me do this one that has squared. So log x squared minus 9 equals 1. Okay, log x squared minus 9 equals 1. Okay, so we have log x squared minus 9 equals 1. Okay, so what's the first thing we do here? Number 1, domain restriction. Domain restriction. So what does the domain restriction tell us? It says that x squared minus 9 should be greater than 0. So that means that x squared should be greater than 9, and that means x squared should be, that means x rather should be greater than plus or minus root 9. So, and that tells us that x should be greater than uh plus or minus 3. Of course, if x is greater than plus 3, it's automatically greater than minus 3. So we can say combined restriction, combined restriction means that combined restriction means that x should be greater than 3. That's the combined restriction. Because if it is greater than minus 3, it's automatically, if it's greater than 3, it's automatically greater than minus 3. So we can then go ahead and solve. Okay. So we then have the laws of logarithm, right? We have using laws of logarithm, we then have log x squared minus 9 equals 1. All right. So that means we have what can we do? So there are many things we can do. We can say this is log 10, or we can use the general thing because this is base. Uh, this now, when you don't see the base, it's more or less like saying you have log to base 10 of x squared minus 9, which is equal to 1. And that means that x squared minus 9 is equal to 10 raised to power 1. And that means that x squared minus 9 is equal to 10. Now, if you don't want to do it this way, you can also come this other way to say, if you see one like this, you have log x squared minus 9. So another way to represent 1 is you can say 1 is the same thing as 1 times log 10 base 10, log 10 base 10. Log 10 base 10 is 1. So in short, we have log x squared minus 9 equals log 10. So you can then equate x squared minus 9 to 10. So, I mean, at the end of the day, this and this are the same. So anyhow you want to do that. So we can just continue with this one now, that x squared minus 9 equals 10. So that means x squared is equal to 10 plus 9. That means that x squared is equal to 19. And then that means that x squared is equal to plus or minus root 19. Okay. Now, what is the domain restriction? The domain restriction says x is greater than 3, right? So here we have two issues. We have this one implies that x, oh, sorry, this is x is equal to minus 19, and then x is also equal to plus 19. Okay. We can then say since the domain restriction is 3, right? X is greater than 3. Since minus 19 is not greater than 3, and 19, since minus root 19 rather is not greater than 3, of course, square root of 19 is like 4 point something. So 4 point something is clearly greater than 3. And square root of 19 is greater than 3. Then x equals root 19. That's positive root 19. Is the only valid answer. Is the only valid answer. Okay? That's the only valid answer. And that's it. So x equals 19 is the only answer we can admit. So with that, I think we come to the end of this interesting video on solving logarithms using the laws of logarithm, or what we call log laws. All right, let me know how helpful this is for you. And if there's something else you'd like me to try out, feel very free to let me know. If you have subscribed to this channel already, I thank you very much for doing that. If you haven't subscribed, what exactly are you waiting for? Go ahead, subscribe, hit the notification bell so you can always get alerted each time a new video is released. Having done that, you can also become a member of this channel to get some special privileges that you find when you click on join. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.